All right, let's go. Let's work through a quiz. The quiz I'm working through, of course, is Exponents and Logarithms. There are two versions of this quiz, and I will do both quizzes in this video. I will start with this one and then go to this one. So look at the first problem, see if yours starts with a 36 or a 40, and that'll give you an indication of which part you should watch. However, if you need the extra practice, you have the extra problem. So here goes. My name is Key. Not really. And I noticed that this is exponential, but I kind of lied. It's not fully exponential. We have some problems with it. We need to get 36 to the other side. So don't be like 36 times 2, not that anybody did, but I recommend that you divide by 36 first. So we're going to divide by 36. And that's going to leave me with 2 to the x over 2. It's an awkward exponent, but it works. And then whatever 80 divided by 36 is. And I'm going to use a calculator instead of Desmos because it just is more convenient in this context to do so. So 2.2 repeating, 2.2 repeating, and we'll carry those decimals with us. At this point, if you would have gotten this far, you would have made the first step. That right there would have been worth one of the things I was looking for. Everything I was looking for was worth 4.5 points. The end of the whole thing, I'll go ahead and tell you now, there were 22 things I was looking for, and they were worth 4.5 points a piece, okay? Just saying. So this is worth 4.5 points. If we can go from here, we'll get the other 4.5 points for this problem. So there were 2 things on this I was looking for. This is an exponential form, truly exponential at this point. So we're going to convert it into a logarithm. I'm trying to solve for a variable in the exponent. So log base 2 of 2.2 repeating, and that is equal to x over 2. You can type it into Desmos. I'll use my calculator, and we'll use as much of that as we can. And that's what we get. So we have 1.152, blah, 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 blah. And then at this point, we just need to multiply both sides by 2. Double both sides, so multiply that by 2. And we have 2.30. And they do want us to round to the nearest hundredth, which is 2 decimal places. But 2.304, the 4 does not round up that 0. So 2.30, you can put the 0 or not. Okay, this also was worth 4.5 points, that final answer. Okay, let's move to the next one. If you could get this first step, then you were on your way. There was really nothing that needed to be moved or done on this one to turn it into the form that it's already in. It is in logarithmic form. So let's just rearrange it. 9 to the 1.5, which is 3x, and that's equal to 3x minus 2. So we are turning it from a log into an exponent. It's a matter of knowing how to turn from exponents to log or logs to exponents for these types of problems. We will find out what 9 to the 1.5 is. Let me digress for just a moment, actually, because I think it's worth saying. We can do this part in our head. It's just fun, planned it that way. 9 to the 1.5. Well, 1.5 is really 3 halves. And this is also sort of part of the quiz. This is really the square root of 9, and then we would cube it. The square root of 9 is 3, so 3 cubed would give me 27. You could have typed it in and got the same thing, but there it is. That's it right there. All right, at this point, we're solving an equation. So add 2 to both sides, write the work or not. 3x equals 29, divide by 3, and x equals 6, whoops, I lied, 9.6 repeating, 9 2/3. So if you would have gotten this far, 4.5 points, another 4.5 points. Let's move to the next problem. So on this one, you could use some of the other strategies where you convert it into a logarithm. It is very clunky to do that way because we have an exponent here and an exponent here. Lucky us, though. Here's something I know, and you know it too. I know what 5 is. If I square it, it's 25. I also know that 5 to the 3rd is 125. And knowing those basic things will help me break this down a little bit. There's a whole chart in your notes with a lot of the really ridiculous ones. These are more common. So 5 squared equals 5 cubed. Clearly not a true statement. We've left off our exponents. We still have 3x minus 1 here, and we have x minus 2 here. So because these bases are the same, there's a big, long process we can go through to eradicate them. In the meantime, let's just skip that and go 2 times 3x minus 1 equals 3 times x minus 2. And then that leaves me with 6x minus 2, which equals 3x minus 6. If you had any of these 3 steps, you would have gotten another 4.5 points. And then we'll just solve it from here. So let's do a bunch of things all at once. We'll subtract 3x from both sides. We'll add 2 to both sides. cancel, 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 and that leaves me with 3x equals negative 4. We'll divide by 3, and final answer, x is equal to negative 4/3, or the decimal equivalent, which is negative 1 1/3. That's also 4.5 points. Okay, moving along. I'm going kind of fast. This is exponential. Let's write it as a log. It would be log base k of d equals v. This is a log. We'll write it as an exponent. P to the w equals d. Just got to know where they go. X to the 7/4. That's all I'm asking. It's the same idea we just had up here with a different problem. That you didn't have to go through all that to get this. All right, now we're getting to the word problems. Here we go. You purchased a stuffed giraffe. It used to be a real giraffe. It's been taxidermized. That means they took a live animal that is now dead and stuffed it. Anyway, you purchased one for $2,070. It increases in value. All right, we're dealing with value of an object, and that is this formula. It is not money in an account, so we're going to use that. And we get to pick if it's plus or minus, and it says increases, so it's plus. So let's just start filling in some numbers. You purchased it, so that's its original amount, so $20.70. And then 1 plus, and then 12%. So do not call it 12. Be careful how many times you move your decimal. It's 2 places, always. So 0.12, put a 0 there if you will like. And we're going to raise it to the time, and it is 5 years. So A equals, and they're saying how much will it be worth? That's truly A. So we're just going to type that in. There was no partial credit on this one. It was all or nothing. 2070, 1 plus 0.012. Basically, whoops. About made a mistake there, 0.12. Basically, there is no solving here. And you might look at that and say, I need a logarithm. And no, you don't. What are you solving for? A. Is it by itself? Yes. So just type that in. Like, really, that's all you have to do. Raise it to the 5th power. And there we go. Your stuffed giraffe that used to be a real giraffe that roamed around and ate leaves is $3,648. And if you want to get technical, 5 cents. I wasn't too picky about the extra nickel on that. Okay, tricky problem coming up. Luis is going to invest $550 and leave it in an account for 6 years. Okay, pause right there. They said account. We're dealing with money in an account. We're going to be using this formula. There we go. Good to know. Assuming that the interest is compounded monthly. Okay, let's just stop right there and start writing everything I know. He invests $550. Time is 6 years. Interest is compounded monthly. I'd love to say that's R. Actually, it's monthly is 12 times a year. What interest rate? Ooh, tricky. To the nearest 0.1%, we'll deal with that later, would be required in order for Luis to have $1,000. If I recall correctly, this one has a ridiculous answer of like a very unrealistic interest rate, but we'll go with it. Okay, 1,000 equals 550. 1 plus, I don't know R, I do know N, I do know N, I do know T. Fill in everything you know and then just look at it and say, well, what do I need to do? Solve for R, that's what you need to do. Okay, what can I do? Well, I can figure out 12 times 6, let's do that, 72. I can also divide by 550 and get that 550 out of the way because it's going to complicate the process over here if I don't. So when I divide that, I will get 1.818181. Trust me, it is. I'd type it in, but don't want to waste your time. You know how to type. All this stuff in parentheses, normally I'd say, oh, let's just clean it up. Like we could have done that here. We're going to do it on the next problem, but this time it has a variable, so we do not have that luxury to do that. That is a 72 because we can figure out what 12 times 6 is. Okay, at this point, we have to solve for R and we got to move this exponent. It is not a logarithm. Logarithms are used, slide up, when I have a variable in the exponent. I do not have a variable in the exponent. So this is not a logarithm. This is going to be, ugly as it is, the 72nd root of this decimal. And again, this decimal came from dividing 1,000 by 550. And then I have 1 plus R over 12. Okay, I'll solve for that in a minute. We're trying to get R by itself. Yes, we'll have to subtract 1 and multiply by 12, but first let's find that. If you go to Desmos, you click the keyboard, you go over to functions and scroll all the way down. It's down there. In the meantime, I will just use this little trick right here. 72 and then 1.81 repeating. We'll just put a bunch of them. Oops, pattern got off a little bit there. probably not going to impact it that far out. So 1.00833.8, I think that's going to be sufficient for what we need. So 1.008338, and that's equal to 1 plus r over 12. We need to subtract 1, showing a little more work than may be necessary. 0.008338 equals r over 12. We're going to multiply by 12, and we're going to get, well, something. Subtract 1, multiply by 12. And I got 0.1000543,154. You don't have to write all that. I'm doing that because of where this is going. If you put your answer like this, I counted it right, but I wanted to go a little further with it. And that would be if you moved your decimal 2 places. So 10, and then we'll take the next decimal, and the 0 doesn't round it up. So 10.0%, 10% is totally fine. This is your rate. So there were 2 things I was looking for on the problem. Of course, the final answer. And just simply the setup itself, and just to be clear on the last problem, I was only looking for that. There's not much really to do on that one. Okay, flipping the quiz over. And a small town has a population. Oh, here we go. Population is not money in an account. It is the value of something or the population itself. That's the formula we use for that. And it has a population of 2013. Grows at a rate of 4% every year. That's 0.04. And to the nearest tenth of a year, wait for it because we don't know years, how long will it take? Okay, we don't know time, but we do know the population after time has elapsed. This one is going to involve a logarithm. Ask me why. Thanks for asking. Because the variable is in the exponent. So we're going to divide by 2013. It was a good year. It was a busy year for me. It's in grad school then. Very busy year. There we go. 1.534. Well, I think that'll be sufficient. 999, that's going to work pretty well. We'll need a log here in a minute. So 1.04, and 1.04, I'm not just making that up. I typed that in. 1 plus 0.04, or do it in your head in this case. And that's to the t. We're ready for a log. So log base 1.04 of 1.534, and that's equal to t. Again, you got to know how to rearrange it. And so I'll do that, and 1.04 of, I'll just use that whole number right there, a little more accuracy, and I get 11.0088. Now they want us to round to the nearest tenth of a year. That's 1 decimal place. So 11.0, and this 0 doesn't round up that 0, so it is truly 11.0. 11 is a perfectly good answer. Just to be consistent with decimals, I'm going to put 11.0, and I'm going to write the word years. Leave that 0.0 off if you like. Okay, on that problem, I was looking for 2 things. I was looking, obviously, for the final answer, and I was just looking for a setup. So if you had that set up, you were good. So each thing, again, that I underlined in red or circle in red is worth 4.5 points. Okay, we're going to sketch the graph of this function. And in order to receive full credit, you have to have at least 2 accurately placed points as well as the asymptote. So I'm just going to jump right in. Desmos is going to be a lot clearer than this calculator, but I'm going to do it this way anyway. To the x, and then plus 1. And I'm going to just go to a standard window, and I'm going to graph it. What you see on the graph here is what I'll put on my paper. Okay. Again, much clearer on Desmos, resolution's better, shows up faster, all kinds of fun stuff. But I do know this much, that I have, and I'm going to put it in red because it was one of the things I was looking for. There is a horizontal asymptote here. So if you had that line, not necessarily drawn, but if you never crossed that line and had the right shape, that was one of the things I was looking for. And then I need a couple other points, and if you want to get technical about it, there's a couple things that I was looking for, and let me see. Those were 2 of the points. 0, 7, 2, 3, 4, 5, 6, 7, and 1, 4. So those 2 points. So if you had 2 points, then you would get 4.5 points of credit. So that's one of the things I was looking for. And then if you had the asymptote, I love that word, that was another 4.5 points of credit. I'm going to draw this one in blue. So the actual graph itself goes like this. Okay, there it is. All right, what is the equation of the asymptote? So this line that you never cross, what is it? Well, this line, if you drew it, and again, you didn't have to as long as you didn't cross it, and it was clear that you were leveling off there. Mine's not too clear, but the equation of the asymptote, it's basically just this horizontal line which crosses the y-axis at 1, and that was worth, you guessed it, 4.5 points. What is the end behavior? So each sentence I write is also worth 4.5 points, and we're going to start two sentences, and we'll go that way. So as x goes, okay, now let's go to the left. Can I go all the way to the left? You might say, no. Actually, yes, I can, because if I squeeze this graph down just right, then this thing's going to go to the left forever. It never stops. You'll see on the other version of the quiz, I'll go ahead and show you, that actually I can't go all the way to the left. There would be a vertical asymptote there, so I can't cross that line. But yes, I can go all the way to the left, and I can go all the way to the right. So I've started two sentences. So let's go all the way to the left. If I go all the way to the left, what happens to the graph? Well, it goes up, and I mean it goes up real fast. So as x approaches negative infinity, y approaches, well, it goes up, positive infinity. That sentence, worth 4.5 points. All right, as we go to the right, what happens? Well, we kind of level off. Yeah, it's decreasing, but it levels off. Levels off where? At 1, which I kind of knew that already. So y approaches 1, just gets closer and closer and closer to 1. So close to 1 that the computers and calculators basically round it to 1 because they don't know any better. So this sentence, 4.5 points. This sentence, 4.5 points. Now the hard one. Let's find the inverse. So the inverse is going to be, well, that with the variables switched around, and we'll solve for y. So I'm going to take that and switch my variables. 6, 1/2 to the y, and then plus 1. And if you just started there, like if you switched x and y, 4.5 points. Lucky you. You can screw up from there, you still got 4.5 points. But now let's keep moving and not screw up. I want to get y by itself, and reversing the order of operations, I will subtract 1 first. So x minus 1 equals 6, 1/2 to the y. Okay, still solving for y. Do not do 6 times a half. Don't do it. This 1/2 has an exponent. The 6 does not the same exponent. So we're going to divide by 6. Cancel those. X minus 1 over 6 equals 1/2 to the y power. A lot of people can get stuck here. It's okay. But this is, it looks weird, but it is exponential. Turn it into a logarithm. The next step, I'll bring it over here. It's a log. What's my base? Half. Log base 1/2 of what? Now, don't expect a number. It's a variable. I'm going to put it in parentheses. X minus 1 over 6. And that is equal to your exponent. That's it. That is your inverse. I'm going to go one more step. This is totally okay. This is a little bit better. There we go. 6.5 points right here. And then you did not have to graph the inverse. If you did graph the inverse, you'd type that into Desmos or your calculator and you'd get an answer and you'd get a graph. It'd be lovely. But you would have an asymptote that would be the opposite variable of that one. So if you graphed the inverse, you would not have an asymptote of the inverse at y equals 1. It would be at x equals 1. You would cross the x-axis at 1 if you drew that asymptote. So this one would be x equals 1. They're always opposite. So some of you, when I was grading the quizzes, some of you would put the wrong variable here, but then put the opposite variable here. Like, for example, in this one, some of you might have put x equals 1. I counted that wrong, clearly. But then if you put x equals 1 here, but put y equals 1 here, this actually would have been right if that was right. So I didn't count that one wrong. Okay, we're moving to the other one. So here we go. That was the first one. Starting the second one. And my name, again, is key. Because this is an answer key. Actually, I already have the answer key, so now I have way too many of them. Let's solve. This is exponential if you move the 40 out of the way. So we're going to go 3 to the x over 2, and we're going to get 60 divided by 40. That's 1.5. Okay? We would type that in a calculator if necessary. It was necessary on the other version of the quiz. And if you got that far, you got, tell them what he's won. You got partial credit. That far will get you 4.5 points. Everything, if you didn't see the first part of the video where I went through the first quiz, let me explain it again. 4.5 points for everything that I mentioned that's going to be underlined in red or circled in red. And there are 22 of those things. 22 things I'll be looking for that are worth 4.5 points apiece. Okay, getting that far got you somewhere. How far? This far. What is that? Exponential. This is now exponential form. Let's turn it into a log. Log base 3 of 1.5. Why a log? I'm glad you asked. Because if I want to solve for a variable in the exponent, I need a log. There's an exception here. We'll deal with it later. Let's type this in the calculator, see what we get. Again, I'm using a calculator, not using Desmos. It's just more convenient for a video. And so 3, 1.5, lucky us, we have calculators. Back in my day, we didn't know this stuff. 0.369, x over 2. I'm solving for x. Let's multiply by 2. That will undo that division. So multiply by 2. And I have 0.738. That is equal to x. We have just earned 4.5 points. 4.5 points again. We're 9 points in. We're on our way. Okay, the next problem is logarithmic. Truly logarithmic from the beginning. There is nothing that can be rearranged. Don't subtract 1. Don't divide by 2. Don't play that game. Don't do it yet. You can rearrange this first like that. We'll start there. 5 to the third is 125. So all we had to do was just rearrange. If you got this far, lucky you, 4.5 points. We'll keep solving. We'll subtract 1 from both sides. That gives me 124 equals 2x. We divide by 2. We get 62. Here we go. You just earned 4.5 more points. Okay, the next one, you can use this strategy if you like. It's going to get really sloppy though. The next one is really fun in the sense that you could just say, hey, I know what 3 squared is. It's 9. I know what 3 cubed is. Oops, 3 cubed. It's 27. And then I can turn 9 into 3 squared. Let's do that. Leave a little space. And I can turn 27 into 3 cubed. Clearly, this equation is false. We need some exponents. 2x minus 4 and x minus 1. Okay, because these are both the same base, mark them out, and I'll have 2x minus 4, 2 times 2x minus 4 equals 3 times x minus 1. That's 4x minus 8 equals 3x minus 3. Any of these 3 steps would have gotten you 4.5 points more. And we will subtract 3x from both sides, cancel those, add 8 to both sides, cancel those, and we have 1x, lucky us, equals negative 3 plus 8, which is 5. Here is your other 4.5 points on that one. Okay, the next 3 problems, it's just a matter of rewriting. You got to know where the numbers go and the letters. That's it. You just got to know. So we're going to write p to the n equals c in logarithmic. This is exponential. Log base p of c equals n. N is the answer to the logarithmic. Let me rephrase that. The exponent is the answer to a logarithmic equation. It is the solution. All right, turn that log into an exponent. So m to the r equals p. When I graded this, I was looking to make sure all the letters were in the right place, and this one was like Mr. P. That's just kind of how I remembered it. And then x to the 12 over 5. You just need to know where the numbers go. It's a good thing to know in a situation like this. It really helps in simplifying. It did on the other version of the quiz, actually. Okay, word problems, 3 of them. You purchased a stuffed giraffe. This is not money in the bank. It is the value of an object, so we will use this equation. A equals p, 1 plus or minus r to the t. We get to choose plus or minus. It is increasing, not decreasing. And the giraffe, which used to be a real giraffe, got stuffed. It died of natural causes, and they're like, I can't part with it. Will you stuff it? So somebody stuffed it. 1 plus, don't put 11.11 is what you put. Per year, how much will it be worth in 8 years? Okay, here's the deal. The only thing you don't know is it's worth in 8 years. Don't get carried away with this and be like, I need logs. No, you don't. No, you don't. I need logs if I am solving for a variable in my exponent. And could have done it here, but it wasn't necessary. Here, there's no variable in your exponent. What are you looking for? A. Is it by itself? Yes. A equals. Type it in. You type all that stuff in the calculator, and you get 30, 50, 1 plus 0.11, 1.11 to the 8. And my giraffe is now worth, that's A, ooh, this is tragic looking. A equals, I was looking away, I wasn't looking where I was writing. Handwriting got really sloppy. We'll use 2 decimal places, not a big deal, because no one will be like, yeah, my giraffe is worth $7,028.84. Yeah, just drop the 84, round it up. Okay, there we go. That's how much your giraffe is worth. This problem, only one thing I was looking for, and that was the final answer. That's it. I mean, if you could set it up, you could just type it in. The next one was a little trickier. Actually, the next one was a lot trickier. Luis is going to invest $650, and it's going to stay in an account for 9 years. He is going to have interest that's compounded monthly. What interest rate to the nearest 1/10 of a percent will be required in order for Luis to have $900 at the end of 9 years? Okay, feeling overwhelmed? Here's what I know. Money in an account. There we go. And I'm going to do this on this problem. I haven't done it on the others. I'm going to list everything I know. $650. Okay, good to know. 9 years. Good to know. Interest is compounded monthly. That's 12 times a year. Good to know. What interest rate? They're asking because they don't know. I want Luis to have an amount, A, of 900. We don't know R. You don't have to list all that. It just helped me organize my thoughts. So now 900 equals 650, 1 plus R over 12 to the 12 times 9. Okay, we will not use a logarithm. Logarithms are used when there's a variable in your exponent, and there's not, so don't. I will instead divide by 650. We're in the process of solving for R, so look for ways that you can move the numbers around R. Let's get rid of the 650 first. 900 divided by 650 is that. I'm going to write some of that. I may not write all of that. 1.3846 will be enough for now, but when I actually compute it, I'm going to use that whole thing. Equals. Okay. Sometimes we can simplify the stuff in parentheses. Not this time. Not this time. Not now. Not yet. There's a variable in there that's holding everything back. But then 12 times 9, I can do that. 12 times 9 is 108. So I do know the exponent is 108. And I look at that and I say, well, I want to get R by itself. So what should I do? I need to take the 108th root of both sides. So here, let me show you what that looks like as we move forward. I want the 108th root, and it's going to wipe out that exponent there, of 1.3846, 1 plus R over 12. So here we go. We are going to take the 108th root of that, and on Desmos, you go to function, you click the keyboard, go to functions, scroll down, it's near the bottom. And in the meantime, I'll do this, 108, 8th root of my last answer. We'll use all the decimals. And I got this answer right here. I'm going to write all that. I'm going to actually write all that this time. So 1.0030177715 equals 1 plus R over 12. Yeah. Okay, solving for R, let's subtract 1. I'm not even going to show the work. 0.0030177715 equals R over 12. Yeah. Now we're going to multiply by 12. We are finding a rate, a percent. So in a minute, we're going to convert this to a percent and round it to 1 decimal place. Notice where I'm pointing, nearest 10. So we will subtract 1 from that, multiply by 12, and we have 0.03621. That's great. Let's just write some stuff. 0.03621. We'll stop there. And if you put this, that's fine. If you put 0.036, that was fine. But to be really clear, my rate as a percent, I'd move the decimal 2 places, and it gives me 3.621, but I don't need the 21. That's too much. They just said 1 decimal place was sufficient. All right. Flipping the paper over. Oh, wait, not yet. I wanted that. And the setup. If you had it set up you were good. If you had the final answer, you were good. Everything I underline or mark is worth 4.5 points. Let's flip this thing over and keep going. Small town has a population. Stop right there and write a formula. We are not dealing with money in an account. We're dealing with population. Grows at a rate of 5% every year to the nearest tenth of a year. How long will it take the population to reach 5,100? Let's do it. 5,100 is the amount after time has elapsed. 3,010, and then 1 increasing? Grows, yes. Plus, rate 5%. Don't put 5, put 0.05. Raise it to the t. We are going to use a logarithm. We're solving for a variable that is in the exponent, so we will use a logarithm. Let's divide first, though. Don't use a logarithm yet. Don't get too crazy with your logs. 5,100 divided by 3010. That's it right there. 1.6943522159. That's equal to, okay, we know what this parentheses is. 1 plus 0.05, that's 1.05. We're gonna raise it to the t. All right, we're ready for a log now. How do you know? We're in exponential form, and there are no numbers like this to be moved out of the way. Everything's simplified as much as we can, so log 1.05 of 1.6943522159. That's equal to t. Once I type this in the calculator, I'm done, actually. T is already solved. It's by itself. So, log of 1.05, log base 1.05 of that, which gives me, all right, we're rounding to a tenth of a year. So, 1 decimal place, so 10.8. 10.8 years. Let's abbreviate that. All right, here we go. Look at that equation. Fun stuff. Type it into Desmos if you like. We're going to get some craziness on this one. We're going to sketch the graph. In order to receive full credit, we have to have at least 2 accurately placed points as well as the asymptote. I think there were only 2 points that really would show up well on this, and they were, I'm going to go ahead and tell you, they were 3, 0, and 7, 3. And some of you, and I don't know why, picked a point over here. You put like 5, 3 or something in it, and that's not it. So I'm going to graph it on my calculator. 3 log base 5 of x minus 2. This is not going to show up well at all based on what you would see on Desmos. I'm actually kind of frustrated with that because on Desmos it goes all the way down. Here we don't have the screen resolution. It doesn't. But it goes down, and I'll draw this. You don't have to draw it, but I am. This is my asymptote. It's my vertical asymptote, actually, and it is at x equals 2. If I drew that, then I would be drawing it where it crosses the x-axis at 2. So let's just go ahead and answer this question here. X equals 2, which of course is worth 4.5 points. You guessed it. Oh, wait, back up. 4.5 points, and the setup was 4.5 points. Just saying. All right, I'm going to draw this thing. That's it. There it goes. There's that. Across that, I have to tell an embarrassing story on the video. Someone runs in and bumps my arm. There we go. That's it. Okay, so you would get, switch colors here, you would get 4.5 points if you had 2 points placed correctly, and you would also get 4.5 points if you had the asymptote placed correctly. All right, now we get to the end behavior, and this is where things get a little bit tricky. So we're going to start 2 sentences, and then we'll finish them as we talk about it. So we have, as x approaches something, okay, that's going to be moving to the left. And then we're going to have, as x approaches something, and that's going to be moving to the right. Let's go. X approaches, all right, we're going to go this way. Normally I would say, oh, x approaches negative infinity. Let's just keep going. Can you keep going? Can you just draw forever this direction? No, you can't. You're stuck. Well, where are you stuck? You're stuck at 2. So as x approaches just 2. Just 2. You're stuck. Now, I can't just say x approaches 2. What side am I approaching from? Because I could come at 2 from this side. I could come at 2 from this side. All right, let's back up. I actually can't talk about coming at an x value of 2 from this side because there is no graph over here. But I can approach 2 from the right. I am moving left, but I'm coming from the right. Okay? So as we approach a value of 2 from the right, what happens to the graph? Up, down. Ah, down. Drastically down. So y goes towards negative infinity. As x approaches, okay, now we're going to go to the right. Can I go forever to the right? Well, I don't want to spend eternity doing that, but yeah, I could. X approaches infinity. So then what happens? Y is going towards what? Does it go up? Does it go down? Does it level off? It goes up. Very slowly, but it goes up. It goes up towards infinity. So 2 sentences. That's 4.5 points. That's 4.5 points. Now we get to this one. Okay, actually, let's not. Let's skip this one. We'll come back to it in a second. What's the equation of the asymptote? If you found the inverse, which we will do in a moment, and you graphed it, then you would have an asymptote not at x equals 2, but you switched x and y, right? In just a minute, we're going to find this inverse, and when we do, and let's just go ahead and jump in, we would take this and call it x, and take that and call it y, and because we switched x and y, we will have switched the vertical and horizontal asymptotes. That, my friends, is the answer to this one. We don't even know the equation for that inverse yet, but we know that much because it's the opposite of this. So some of you on your quiz got, for example, on this problem, you might would have put y equals 2, and that would be wrong. And so I counted it wrong. But if you put y equals 2 here and then x equals 2 here, I didn't count this one wrong because I wanted to know that you knew that these were opposites. So if you missed this one but put the opposite variable for this one, you were fine by me. Okay, I gave you credit for one of them but not both. So let's move on. I'm going to solve for y. I'd love to go ahead and be like, oh, 5 to the x, like turn it into an exponential. Let's not. Let's divide by 3 first. It's going to make it much easier. Trust me. X over 3 equals log base 5 of y minus 2. Okay. Oh, now it's logarithmic. 5 to the x over 3 equals y minus 2. Yay, okay, we're going to solve it for y. We're just rearranging things. Get y by itself, so y equals 5 to the x over 3. We'd have to add 2 to the other side, and we're done. So I will go one more step because I am finding an inverse, and I'll call it what it is. That is 5 to the x over 3 plus 2, and here goes, final answer. If you got the final answer, that's 4.5 points. If you actually just started the problem by switching x and y, you got 4.5 points there too. Like as long as you could switch your variables and jump off from there, you're good. All right, there are both quizzes right there.